7.3, solving equations using multiplication or division. Okay, so I want to start off with having you, with your notes, I want you to kind of go through and write down most of these, okay? And I'll show you once I get my highlighter. There we go. So 7.3, and then I want you to write down key idea, or ideas. Multiplication property of equality. So, this is what I want you to write down. When you multiply each side of an equation by the same non-zero number, the two sides remain equal. So just like we did in 7.2, where we were trying to get the variable all by itself on one side, we're going to do the same thing in this section, only now we're dealing with multiplication and division problems. So in words, I want you to write that down. In numbers, it looks like this. If I had 8/4 equals 2, again, we have to take and balance those sides, okay? So if I'm going to balance this side of the equation to equal this side of the equation, how do I do that? Well, down here, what they did was they multiplied the whole thing, okay, 8/4 times 4. If you're going to do that over here, you have to do it over here. And what that means is I'm getting down to 8 equals 8. Now, if you think about it, how many times can 4 go into 8? Okay, 2 times. Does 2 equal 2? So our whole idea here is to balance it out. Using it with numbers is a little bit more confusing, so let's look over at the algebra side of it, because that's what we're going to be practicing. So I've got x over 4, okay? And it equals, it equals 2. Pretend that's not right down the middle of the 2. What I have to do to get rid of the 4 in this situation is I have to multiply it by 4. Okay, so I want you to look at it like this, like we practiced a long time ago. If I had x over 4 times 4 over 1, that's what this is showing right here. I can cross factor those out. It gives me x times 1, which we know just equals x. 1 times 1 equals 1. We know 1 can go into x, whatever that x might be, can go into it as many as the x allows. So that leaves us just with x. But what we have to remember is if we are going to multiply this 4 on this side of the equation, okay, over here, we have to do it on that side. So that's why we do 2 times 4 gives us 8. What they're telling us is that x equals 8. We're going to do a lot more practice with that, but I wanted to just show you by putting this information in why that gets rid of any number. And I'll show you that again as we go. Okay, multiplicative inverse property. This one's a little bit trickier to understand, but let me kind of go through it and try to help you understand it. So first of all, I want you to write down multiplicative inverse property, okay? In words, it means the product of a non-zero number, n, and its reciprocal, 1 over n is 1. Remember, we are talking about a non-zero number. So that's any number except for 0, okay? So let's look at this in numbers. If I had 5, and I want 5 like to be gone, I want it to be down to 1. The way I would do it is I would take my 5 and I would multiply it by its reciprocal. Remember, 5 as a fraction is over 1. So its reciprocal is 1/5. So what that's telling us is that that should equal 1. Well, check it out. 1, 1, okay? 1, 1. Because 5 divided by 5 is 1. 5 divided by 5 is 1. So now I have 1 times 1 equals 1. 1 times 1 equals 1. 1 divided by 1 is 1. So what that means in the algebraic world, which is what we're going to be working with, is that if I have n, and I want to get that all by itself on a side of a, on side of the equation, I can multiply it by its reciprocal. And I should be able to get it down to 1, okay? So n, and please write this down, n times 1 over n, which is its reciprocal, should equal 1. We all know that 1 or n will not be able to equal 0 in this situation. Okay? I know that's kind of tricky. You'll see that come into play here soon. And then I also want to point out this box over here. Okay? Remember, inverse operations undo each other. Multiplication and division are inverse operations, just like addition and subtraction are inverse operations. Example 1 is solving equations using multiplication. Here are our directions. Solve, okay? So we are just going to solve these problems. We're going to start off with, and this is exactly how I want you to set this up, so don't try to go a different route with it. Again, next year, this is how your teachers are going to have you set it up, so please do it similar, or exactly, I should say. So we have W over 4, which is a fraction, and it equals 12. How do we solve for this? So what we need to do is use the multiplication property of equality, which is what we just talked about up there. And we need to get rid of the 4 over there. We want W all by itself. In order to get rid of the W, we have to undo the division, okay? And to do that, we multiply it over here by 4. Because when I do that, it's 4 over 1. Technically, this is 1W, right? So if I have 1W over 4, I multiply it by its reciprocal, which is 4 over 1. This gets rid of the 4. Now I have W over 1, which we just learned equals W, okay? So if I multiply it by 4 over here, I also have to multiply it by 4 over here because I'm balancing this equation. 12 times, and this gives me my W down here. I should have put that. 12 times 4 equals 48. And that becomes my answer for W. And then you have to do a check, just like we've done before. So I've got W over 4 equals 12. Now I'm going to plug in 48 over 4 equals 12, because that's what I said W equaled. 4 goes into 48, 12 full times, and it equals 12, and that's my check. So this needs to be written, and this needs to be written. You do not need to show me, let me get a highlighter here. You do not need to show me this part of it, like doing the cross factoring. You just need to put W over 4 times 4. Because that's getting my W all by itself. Let's try a little bit more challenging problem here. So if I have 2/7 times x equals 6, remember that when I have any number right next to a variable, that means multiplication. Okay, that's from prior chapters. We have to remember that. All right, so what I need to do is get rid of 2/7. If I multiply it by its reciprocal, I can get rid of it. So I'm going to start with 2/7. I am going to multiply it by 7/2. Do you see how that gets rid of each other by crossing them out? And it gives me 1 over 1. Now I have 1 over 1x. Okay, I'm actually going to erase that. I just want to prove to you that that's what I get from it. So in other words, what happened is I got 1x, but I don't need to write that 1 before that x. That's kind of important because I feel like kids get really confused if I put that 1 there. We always know it's for sure 1 because 1 times anything equals whatever that number is. All right, so if I did, and I multiplied 7/2 on that side, I also have to do it over on this side. Okay, and then this is where the math part comes in. Put it over 1. I can do cross factoring because 2 can go into 6. 6 divided by 2 gives me 3. 2 divided by 2 gives me 1. If I go straight across, 3 times 7 is 21 over 1. So that gives me 21 on this side of the equation. This side, I have an x, okay? So I solved it with x equals 21. My check would look something like this. So I have 2/7 x equals 6. I fill in what I have for my x, 2/7 times 21 equals 6. So now I just have to multiply the two of these. This would be over 1. I can go and make that smaller because 21 divided by 7 gives me 3. That's a 1. Let's get my pointer out here. Come on. There you go. 2 times 3 gives me 6. I don't do anything over there. This is just my check to make sure 6 equals 6. So this is my work, and this is my work. That's what I would show for a problem like that. Okay, our next one is, I want you to skip a line and write key idea, our division property of equality. So we just learned about the multiplication property of equality. This time, it's with division. And honestly, I think this is easier because you're not dealing with fractions quite as much. So I'll show you that in a minute. So please write this down. When you divide each side of an equation by the same non-zero number, the two sides remain equal. Again, we balance out each side of that equation. When I say each side, on the left side of the equal, the right side of the equal sign, okay? All right, so let's look at it in numbers. If we had 8 times 4 equals 32, okay? We could divide both sides by the same number, and we should be able to come up with an answer. So 8 times 4, if I divided it by 4, I would get just 8. Okay, and that's what I did right here. Then whatever I did on this side, I have to do on this side. If I divide that by 4, 32, I also get 8, so I can balance it out. Now, you might just say, well, Mrs. Taylor, why didn't we just look up here and multiply 8 times 4 to get 32. 32 equals 32. That's true, but all I'm doing is proving to you that if I divide this on this side and I divide it on this side, I come up with still balancing that equation. Let's look at it algebraically. So now I have 4x equals 32. If I divide 4x divided by 4, this is another way to look at it. You could also do it like this, okay? I like to put it underneath like this too. It makes more sense because I can just say 4x divided by 4. I get rid of my 4, get rid of my 4, and I'm left with an x. 4 goes into 32 8 times. So we know that 8 equals x. And to prove it, I would just put it in. I would fill in my 8. 4 times 8 is 32. So it works. Okay? All right, let's do a practice like this. All right, example 2, solving an equation using division. Same exact directions apply. Solve. Okay? So what they give us is, the first one is 5b equals 65. Now I know a lot of you are looking at that and you're like, I already know the answer. That is great, wonderful. I'll just tell you the answer, it's 13. That is simple, but again, these get more challenging, and I want you to make sure that you understand how to take the notes and how to do the work correctly. So here's how you would solve this using the correct work. So first of all, if I have 5b, our goal is to get 5 out of there, right, on this side of the equation. We want these to be balanced. Right now they're not. So to get rid of 5, I have to, I'm actually going to erase that line so I can show you this. I'm going to divide this by 5. We know that 5 divided by 5 is 1, okay? So we're going to undo the multiplication right there, and that will leave us with b all by itself. Now, if I divide this on this side by 5, I have to do the same thing over here. 65 divided by 5. 65 divided by 5 gives me 13. And I already told you that was our answer. So now when I go over here and I check it, I've got 5b equals 65. I leave my 5. I'm going to plug in, that's a multiplication sign, sorry. I'm going to plug in my 13 equals 65. 5 times 3 equals 65. And now we know that it balanced. So you would have to show me your check work, and you would have to show me this. I don't expect you to put those little signs on to see the balance side. I'm going to show you what I mean in the next one every time. All right, let's do one more. All right, 12Q. Oh, I lost it. 12Q equals 60. Again, we know the answer. You should know that 12 times 5 equals 60, okay? That is the correct answer. However, showing how you got to it is, again, more important than just not solving, not understanding how you solve it, okay? So the first thing I want to do is get Q all by itself. I'm going to get rid of 12 by dividing it out, okay? So 12 divided by 12 gives me 1, which leaves me with Q. I don't have to write 1 there. I know that it's 1, okay? And then whatever I do on the left side, I do on the right side. 60 divided by 12 equals 5. So now I found that Q equals 5. Pretty simple, right? Like I said, this is easier than doing multiplication in my opinion. So now I just do my check. I've got 12Q equals 60. Then I do 12 times 5 because I plugged in my Q equals 5 equals 60. 12 times 5 equals 60. And there's my check. Okay? So these are the two pieces of work that I need to see in order for you to get credit on something like this, okay? Here are two to try on your own, and then I'll post the answers right after. So let's do the first one. If I had P times 3 equals 18. And then I had 81 equals 9R. Just because, this is number 2. Oh, come on. There we go. Just because the R is over on this side, my variable, doesn't mean I can't do it. And then look at this one. Kind of tricked you. See if you can figure these out this way. I'm going to put a little hint right after. Okay. So 3, I could just switch the way this looks and do it this way. And then you should know I get rid of my 3. Okay, hopefully you got to this point, which would get me down to P. 18 divided by 3 should give me 6, and that would be my answer. My check would be just this simple. I'll change my color here. 6 times 3 equals 18. Whoops, I didn't put in the P, did I? That's okay. That means 18 equals 18. Okay? All right, let's look at the next one over here. I've got, if I'm going to leave it like that, that's fine. I could also flip-flop it, but I'm going to get rid of my 9, get rid of my 9. So now I'm balancing that out. That gives me R by itself. 81 divided by 9 should be 9. So that gives me R equals 9, or 9 equals R. Doesn't matter which way you put it. Then if I go and I do my check, 81 equals 9 times 9. 81 equals 81. So it's not too bad. I mean, you're going to deal with, you might have some other harder examples with bigger fractions or something like that. So do your best. I do want to show one more example that you'll have on your practice that will, and I don't want you to be confused. So here will be the next one. One more. So this one looks a little confusing. It's really not. All you need to do is rewrite it. And there's a couple of them like that where they put the variable next to the 3 like that. So it's 3R divided by 4. All you got to really do is just pull that out. So in other words, this is how you could rewrite it. 24 equals 3/4 R. And what we should recognize here is that we have to divide this side by its reciprocal and divide or multiply this side by its reciprocal. Sorry, I said divide. So basically that just gets rid of this. I know that R is in the middle, but that gives me R by itself. And then I can go to the other side, put that over 1. I can cross factor. Again, you don't have to cross factor, it just helps significantly. 24 divided by 3 is 8. So now I have 4 times 8 is 32, should be my answer. And then when you do it in your check, I should have, I'll do it over here, I'm running out of room, 24 equals 3/4 times 32. Okay, you could also do 3 times 32 and do it over 4, but we'll just do it this way because that's how we set it up differently. Put this over 1, 4 and 32. I can do like that. 3 times 8 gives me, oh, that's a bad 2. 24. Okay, so 3 times 8 equals 24. I don't need to do my 1 times 1, and that checks out. So you can see that you can kind of manipulate how it looks just to make sure you're figuring out. Don't get yourself confused by it. You might also see one more like this that gives you 9 equals V divided by 5. Well, you can just switch it to 9 equals V divided by 5. Okay, and then we know we can do the reciprocal, and that would be 5/1. That gets rid of my 5's, right? So now they become 1's, which gives me V by itself. So I'm going to do the same thing over here. Multiply that by 5. Technically over 1 if you want to go that route. 9 times 5 is 45. So what the answer should be is V equals 45. So let's just do a quick check. 9 equals 45 divided by 5. 45 divided by 5 equals 9. There's my check. Okay, so don't get confused when you see something like this. Just write it the way that makes more sense for you. If you just know that you would divide or multiply that by its reciprocal of 5/1, that's fine. But don't get too confused over that. All right, and that finishes 7.3.